Hello, my name's Carsten, and I'm in charge of transmission design at M GmbH. Today I'd like to tell you something about the M Steptronic transmission. This is the M8 HP76 transmission, which we know from the M5 M8. Here's the connection to the engine. Here on the outside, the flange to the crankcase. On the inside, the connection to the crankshaft. Back here, the connection to the drive shaft via a flexible coupling. And here on the side, the connections to the transmission oil cooling. The small lever here is the emergency parking release, which is needed in the factory and possibly in the workshop. This is a cross-section of the transmission. Engine flange to crankcase, crankshaft flange to crankshaft, the torque converter lock-up clutch, the turbine torsional damper, which is the equivalent of the dual-mass flywheel from the manual transmission, the torque converter itself, the drive for the oil pump, 1, 2, 3, 4 transmission planetary gear steps, and 1, 2, 3, 4, 5 clutches as shift elements. Here at the back, the output to the drive shaft. Theoretically, with 4 sets of planetary gears, it would be possible to create 256 different gear ratios. That wouldn't make much sense, so we decided on 8, or 9 with reverse gear, which are then engaged via the shift elements. 3 shift elements are always closed and 2 open. That generates minimal drag torque, low fuel consumption, low power loss, and at the same time always enables 1 clutch to close and 1 to open, and thus smooth, fast gear changes. At the lowest possible revs, the torque converter lock-up clutch is closed. After that point, we're directly connected, as in a double-clutch transmission or manual transmission, purely via shift elements and gear wheels with the output. Shift speeds of up to 150 milliseconds are possible, allowing very quick sports gear changes. Now I'd like to talk about how the M8 HP differs from the standard AG8 HP. We've taken some measures in order to do justice to the higher performance of our vehicles. First, we have a narrower spread than the standard BMW AG vehicles, namely 7.8 with very even steps, so that we can enable very gentle or very fast direct gear changes and don't get big rev jumps between the gears. That enables, on the one hand, very high performance and exact rev matching on the racetrack, and on the other, low rev touring and low noise levels in the upper gears in everyday driving. In our M transmission, we also installed additional cooling for 1 shift element. That's why we supply it with more oil, so that we can close the element faster and harder, which enables sharper, faster gear changes. We've also changed the oil sump. The standard BMW one is made of plastic with integrated oil filter. On the M, it's made of aluminium with a separate oil filter. That's for 2 reasons. First, we have a deeper oil extraction point down here, so that we make sure we have oil in the system at high levels of lateral and longitudinal acceleration. You can see here the additional indentation in the oil sump. We've also got additional heat dissipation via the ribbed structure on the underside. In doing so, we made sure that we achieve full racetrack suitability, even with the torque converter transmission, which, as we've seen, worked very well with the M5. These 4 feet have no function in the vehicle, they're just there to support the transmission if it has to be taken out of the vehicle. So, of course, the question arises, dual-clutch transmission in the old M3 M4 compared to 8 HP in the new M3 M4. What are the advantages and disadvantages? We examined both transmission concepts closely and had to take a decision that is, of course, related to the overall vehicle project. In the meantime, with the torque converter transmission through the converter lockup clutch and the direct clutch-to-clutch shift, we now have in principle all gears pre-selected and can decide directly via the clutch and the control electronics which gear we want to use. Whereby with the double clutch transmission, just one other gear can be pre-selected, which means that you can shift very quickly into this gear. If you decide on a different gear, then the gear change is not optimal. That's not a problem here. Yes, changing gear with the double clutch transmission is even faster and sharper with the optimal gear because it can also use inertia, which we can't with the torque converter transmission. All in all, it's always a question of the whole package, and in this case we decided on the torque converter transmission M Steptronic as we had good experiences with it in the M5. I think the gear change is pretty close to perfection, both as regards speed and comfort.
Komfortabilität angeht.